Hi, welcome back to Advanced Functions MHF4U1. This is Trigonometric Identities and Equations chapter. In this lesson number 2, we are going to learn about what is a compound angle formula. First, compound angle formula, what it is, it's a compound angle that is made by either adding or subtracting two or more same or different angles. So in simple terms, when you're adding or subtracting two angles, we call that a compound angle. So for example, 70 degrees or 75 degrees is a compound angle because using a special triangle, so for example 30, we looked at 45 and 60 degrees. 75 could be broken down into 30 degrees plus 45 degrees. So using the special triangle, 75 degrees is a compound angle. And using sine, cosine, and tangent, we can figure out the exact value by using a special triangle. If it doesn't involve a special triangle, that means you will get a decimal answer for your expression. So first, addition formula. So these are the three addition formulas that you have to know how to use them. So for example, let's assume that we have two different angles, alpha and beta. So sine compound angle of alpha plus beta is equal to sine alpha times cosine beta plus cosine alpha times sine beta. Now I can't stress enough that the order of the equation is very important, and the angle that is attached to the trigonometric ratio is important. So it has to be sine alpha times cosine beta. It cannot be sine beta or one or the other. Okay. What about cosine? So cosine is cosine alpha times cosine beta minus sine alpha times sine beta. So you will notice that it's very similar to sine for the compound angle, but except that cosine is together with two different angles, subtracting sine of the two different angles. And lastly, we have tangent, which is, it's a fraction, tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Okay, so please keep in mind, you don't have to memorize it necessarily, but you need to know how to use it. Now this is a subtraction formula, so we have sine alpha minus beta. So in this case, it's a similar to sine, but this time it's the same pattern, but it will be subtraction for sine. On the other hand, for cosine, it's going to be positive, adding. And tangent, you will notice that it's subtraction over here and addition over here, but it's the same pattern of the terms. Okay, so let's do a practice question of how we can use this compound formulas. Question is, write the following a single trigonometric ratio. So first thing is to identify how this expression looks similar to which formula. So we have alternating sine and cosine plus cosine and sine. So just by looking at it, this looks very similar to sine x plus y. So don't forget, the order is very important. So it's going to be cosine x sine y plus sine x and cosine y. Okay, So as you can see, I could say that in this case, I have angle A, the x, which is 3A, and angle y, which is A. So I can simplify this expression using the formula, which is sine 3A plus A. So if it's exactly the same formula, except the angle is different. So angles are represented using 3A and A. And I could simplify inside the bracket by collecting like terms. So sine 4A. So this is a single trigonometric ratio, and I could expand this by writing it as a compound formula by breaking into 3A and A. Next, so take a look at the formula, the equation, and you will notice that it contains tangent. So it must be a tangent compound formula, but you will notice that the numerator is positive. So if it's positive, the formula, the standard formula, must be tangent x plus y. So it will be tangent x plus tangent y over 1 minus tangent x times tangent y. Do you notice that it follows exactly the same pattern, except the angles, I can replace it with a numerical value. In this case, it will be tangent. So x is 3 and y is 5. Therefore, the single trig ratio is going to be tangent 8. Question 2. So write the following as a single ratio and then evaluate it. So again, let's figure out what compound formula that this follows. So we have alternating sine, cosine, cosine, sine. So you will notice by looking back to your formula sheet, this is very similar to sine x minus y because it's alternating. So the formula, the standard formula, is sine x cosine y minus sine y cosine x. Now, so you will notice that I started with sine y cosine x, but this could be interchanged because it's multiplication. So I could write it as cosine x and sine y, as long as the angles are consistent. So therefore, I can replace this. So sine x, in this case, it starts with pi over 2, subtraction pi over 3. And you can double check by plugging in the number into x and y. So let's collect the same denominator. It's going to be 3 pi over 6 minus 2 pi over 6. So therefore, it's going to be sine pi over 6. Now, pi over 6, let's do a reminder. It's a special triangle. Okay, so we have pi over 3. We have pi over 6. And sine is opposite over, so it's going to be 1, 2, square root 3. So it's going to be, so starting from this angle, it's going to be opposite over hypotenuse. So it's going to be 1 over 2. And that will be my final evaluated answer. Okay, next, letter B. So it seems like we have a tangent. So it must be a tangent compound formula. And in the numerator, it's subtraction. So it must be tangent x minus y. Let's write down the formula. Tangent x minus tangent y over 1 plus tangent x times tangent y. So it looks like x could be replaced with pi over 2, and y is replaced with pi over 6. So equal sign, tangent, pi over 2 minus pi over 6. So make a same denominator. So this is going to be 6, 3. So it's going to be tangent pi over 2 pi over 6, which is tangent pi over 3. So using a special triangle, so pi over 3 is over here. This is my starting angle. It's going to be opposite over adjacent. So therefore it's square root 3 over 1, meaning it's going to be square root 3. So this is my evaluated answer. Or tangent pi over 3 is going to be a single ratio representing the compound angle formula. Next, determine the exact value of sine 5 pi over 12. Now, so as soon as you see the question exact value, that means they want you to put it in a special triangle, which is 45, which is pi over 4, 30, which is pi over 6, and 60, which is pi over 3, okay, and etc. So let's see, I need to break down 5 pi over 12 to look like using a special angle radians. So if it helps you, you could change 5 pi over 12 into a degrees to figure it out. So 5 times 180 divided by 12. So this is 75 degrees. So just by looking at it, 75 degrees can be broken down into using 30 degrees and 45 degrees. Okay, one or the other. So that means 30 degrees is going to be pi over 6, and 45 is going to be pi over 4. So let's break it into a compound formula. So sine, so I will start with 45. So pi over 4 plus pi over 6. Okay, now using this formula, I'm going to plug it in. So sine compound addition formula starts with cosine pi over 4, sine pi over 6. Now again, they could interchange the order as long as the angle is same with cosine and sine. Okay, because this is multiplication, you can interchange it. And plus cosine pi over 6, sine pi over 4. So this would be the compound formula using writing the expression. Now, because we're looking for the exact value, let's evaluate what cosine pi over 4. So on my I'm going to make a triangle, which is pi over 4, pi over 4. The formula of the triangle looks like 1 square root 2. Make sure you memorize the special triangle. It is a must. Pi over 6. This is pi over 3. It's going to be 2 square root 3. So using this formula, so this is my starting angle. Cosine is adjacent over hypotenuse. So it's going to be 1 over square root 2. And then sine pi over 6. So this is my starting angle. It's going to be opposite over hypotenuse. So it will be 1 over 2. So what I'm doing is I'm evaluating each term. Plus cosine pi over 6. So pi over 6 here, cosine is going to be adjacent over hypotenuse. So it's going to be square root 3 over 2. And sine pi over 4, so it's opposite over hypotenuse. So it's 1 over square root 2. Okay, so let's evaluate. So when I multiply, it's going to be 2 square root 2 multiply again, square root 3 to square root 2. And unfortunately, it's the same denominator, but it's different numerator. So we can't really add it. It's going to be 1 plus square root 3 to square root 2. Okay, so what we could do, we could multiply the top and bottom by rationalizing square root 2, square root 2, so that this cancels out with this. So we are rationalizing the denominator. Therefore, it's going to look like, so I'm going to distribute property, square root 2 plus square root 6 over 2 times 2. So square root 2 times square root 2 is 2. And I could evaluate, it's going to be square root 2 plus square root 6 over 4. And this would be my exact answer of sine 5 pi over 12. So without using a calculator. Next, find the exact value of tangent pi over 12. So again, if it helps, why don't you change the radian into a degrees? So I'm going to do pi over 12 times the conversion formula, 180 over pi, and I get 15 degrees. So think about how you can use these special triangles to get 15 degrees. So it would be 60 degrees minus 45 degrees. That will give me 15 degrees. So I just made a compound angle. So therefore, let's use the tangent formula because it's a tangent ratio of a subtraction. So tangent, it's going to be 60 is pi over 3 minus 45 is pi over 4. So let's plug in the angles into the standard formula. So it's going to be tangent pi over 3 minus tangent pi over 4 over 1 plus tangent pi over 3 times tangent pi over 4. So what we're going to do now, we are going to evaluate this. So again, you have to have that special triangles handy. Okay, so if it's pi over 4, 1 square root 2, 1. If it's pi over 3, pi over 60, so pi over 60, so it's 1, 2 square root 3. So tangent pi over 3. So pi over 3 is here, so this is my starting angle. It's going to be opposite over adjacent. It's going to be square root 3 over 1, which I omit, minus tangent 45. So this is my starting angle, pi over 4, opposite over adjacent, 1 over 1, which is 1, over 1 plus tangent pi over 3. Tangent pi over 3, we said it's going to be square root 3. And tangent pi over 4, we said it's going to be 1. Okay, so let's simplify this. This is going to be square root 3 minus 1, 1 plus square root 3. So we don't want to have a radical in the denominator, so we are going to rationalize it. So we are going to rationalize the denominator. So it will be a conjugate because it's an expression. So I'll be multiplying the conjugate of 1 plus square root 3. So it's going to be 1 minus square root 3, 1 minus square root 3. Okay, remember the conjugate is the same number but a different sign. So for example, conjugate of x plus y, it's going to be x minus y. So you do this when you're rationalizing the denominator. So therefore, The denominator, it's going to be 1 minus 3, right? So for this one, you have to do a FOIL. Front, outside, inside, and last. So square root 3 times 1 is square root 3 minus 3 minus 1 times 1, 1, and negative negative becomes positive square root 3. So I'm just going to go sideways. So let's collect the like terms. So that we have 2 of square root 3. So 2 of square root 3 minus 4 over minus 2. Okay, and we could definitely simplify this. So because it's an expression, negative 2 has to be divisible by the first term and the second term. So I could divide everything by 2. So therefore, it's going to be negative square root 3 plus negative negative becomes positive 2. So therefore, my exact value of tangent pi over 12 is, I'm just going to reorder, 2 minus square root 3. And that will be my final answer.